Welcome to the Croning Museum Glass and our hot glass show. This is Catherine Ayers. She'll be our glass maker for this demonstration. My name is Michael. I'll talk about the process. I'll explain everything and answer your questions along the way if you have them. I'll help Catherine out a little bit as well. But she's begun. She collected clear molten glass from the glass melting furnace. This glass is 2,100 degrees Fahrenheit and it has that bright orange glow because it's so hot. Now, glass out of the furnace, we need to organize it. That's what Catherine does. She shapes this on the end of a pipe. We use these wet scoops, these wooden tools, to organize the glass so she can begin the glass blowing process. Now, she will connect a hose to the end of the pipe. And this hose is an auto-inflation system. So we can step on a pedal, which activates compressed air. The air flows through the hose, through the pipe, and into the glass, just like that. If you were watching closely, you may have seen that glass grow and expand as the air forces its way into the soft material. Now, for 2,000 years, as glass makers, we put our mouth on the end of the pipe, we blow through the pipe, and we inflate glass that way. But in the last couple of years, we started using this auto-inflation system because it allows us to do a couple things. We can inflate glass, we can shape glass simultaneously, and we have a really great view of what's happening so that we can see exactly how that glass is changing. Now, really, we created this system as a result of mask wearing, but it's a really effective tool that we've kept in place. So this is only a small amount of glass. To make something larger, Catherine needs more material. So she'll go back to our furnace to get more glass. I started an animation on the screen so you can see what it looks like in this furnace. 1,000 pounds of molten material sits in a large ceramic bowl. We push the pipe down beneath the surface. We turn and we spool the additional layers right on top of that initial bubble. Now, with every subsequent gather, we do get more and more material. If we try to get this much glass that first time, all of it would just run off the end of the pipe. It would drip all over the floor because that glass is too runny to support its own weight. So a larger wooden scoop shapes, centers, and cools that fresh glass around that first bubble. These wood tools, soaked in water, last a couple of years before we have to replace them. The water turns to steam and then the glass glides on the layer of steam within that tool. So while we cool off that fresh layer of glass, that internal bubble, it's warming back up, it's softening so that we can continue shaping and inflating. So first we get that glass distributed evenly. Catherine changes the angle of the pipe, that changes the distribution as well. A little bit more inflation. That time, the traditional method, putting your mouth right on the end of the pipe. And then we can continue shaping and contouring glass with our hands. We do, however, have to have a barrier in between 2,000 degree glass in our hands, so we use newspaper. It's about 7 to 10 sheets of newspaper. We fold it up, we soak it in water, and we can just shape the glass with our hands. So it works just like those wood blocks. The water turns to steam, we can shape it up. Now, when we are using those wet tools, the glass is cooling rapidly, so we have a reheating furnace on the left side of the stage. We reheat the glass. As long as we keep reheating it, we can just keep working. We keep it soft, we keep it malleable. If we let it cool down, it becomes rigid. It stops moving, we can't change it any longer. Now, Catherine has gotten the glass hot, so she can drop it into a mold. We have a series of molds, different shapes, sizes, different internal textures. She drops the glass into the mold, she inflates, and she picks up texture on the surface. Now, she dropped into a second mold, and she's not using that to get additional texture, but instead, she's turning the pipe inside of that mold, and the friction from that twists up the texture on the surface. So by turning into the mold, she twists it up, and then she did inflate a little bit further. So she used that for 2 different, basically, ways to shape the glass. Let's see. Well, it's not too hot. Actually, it's very nice and warm. I can hold this pretty comfortably. But you can see all the ridges inside of this mold. We inflate and pick up the texture, and because she used 2 molds and she twisted the texture off of the first mold, we get kind of a cross-hatched pattern. Now, we do have to work quickly and efficiently from here on out. If we overheat the glass, if we overwork the glass, we can melt the texture completely out. Glass naturally wants to ball up. It naturally wants to be smooth. So after a brief reheat, you'll see Catherine do a lot of shaping and a lot of inflating in this next move. At this point, the glass is still fairly condensed. It's thick, so it's going to stay hot for a long time. But once we begin inflating it, once we begin stretching it, and the glass gets thinner and thinner, it's going to start cooling and faster and faster. So it's thermal mass. That's what we think about. It's just like if you have a bowl full of soup, the bowl of soup is going to stay hot for a long time. whereas just a small amount of soup on the spoon is going to cool off really quickly. So once the glass expands and it gets thinner, it's going to cool faster and faster. So Catherine's working time will shorten throughout this entire process. So she inflates this. Small steps and stages. She presses on that pedal, adding air just a little bit at a time. This amount of glass, she could easily blow it up bigger than a beach ball, thinner than cellophane. In fact, we can blow our glass up so thin, we can pop it. And while that is very exciting, it makes for a fun little demonstration of how glass can stretch, it does make a very short demonstration. So we have to add the air just a little bit at a time. And what we rely on is that glass expanding and then cooling to develop a little bit of structure. And then we can blow it up a little bit further. But if we blow it up too quickly, it can collapse in on itself or we pop it. So now we have a nice big bubble. You can really see the optics, the way that the light interacts with the glass. You can see how it's not just clear to look through. It has this really cool surface appearance, fun little rippled design. At this point, Catherine's all done with the glass blowing. Glass blowing is a really small part of what we do. Did you say a foot? All right. So we're all done with the glass blowing. But we're not done. We are going to add some additional material. Hot glass sticks to other hot things. So I've collected some glass from our furnace, and we'll stick this right onto the bottom of that bubble that Catherine has. So this glass that I have, it's got that bright orange glow. It's very clear that it's hot. The bubble that Catherine has doesn't look nearly as hot, but it is still well over 1,000 degrees. And we know this because it's not broken. As glass cools, it shrinks and it contracts. And if that happens too much too quickly, it'll break itself apart. So we rely on our experience, looking at the glass, knowing how hot it is based on the way it moves, what the temperature is. So we've added this bit of glass onto the bottom. This is a great example as well as how malleable that material is. Catherine uses some tweezers to twist and make a little ruffled design on the edge. We'll work together to finalize the profile of the foot, and now we're all done with the bottom of the vessel. So traditionally in the handmade process, we work on the bottom of pieces first, and then we break them from the blowpipe that we make them on onto a secondary handle, a secondary iron, which is what I'm going to start working on now. So we call this the transfer process. We're transferring glass from the blowpipe onto this punty, this temporary handle. And this is really one of the most precarious parts of the process because we do have to break glass. So to be a good glass maker, you have to be a good glass breaker. Catherine created a constriction just off the end of the pipe. And that constriction is how we'll break the glass from the blowpipe. And that will then become the top and the opening of this object. So we balance out the temperature using that torch because that foot, that's fresh glass from the furnace, still very hot. So we balance out the temperature. We'll put this punty on. We do not want this to be nearly as hot as the foot because the foot permanently fused right onto the bubble. We want to be able to break this punty free later on. To remove the glass from the blowpipe, a couple drops of room temperature water creates thermal stress, creates those little cracks in the surface, and a light tap is all it takes to break the piece free. I say we give Catherine a big round of applause for breaking glass. Nicely done. Now the other thing that can happen is if we let this get too cold, when we go to break the glass, it'll shatter, just like glass breaks at home. So we lose a lot of things in our early days as glass makers. Nothing is telling us the temperature of the glass aside from our experience. So we make a lot of really bad guesses in our early days as far as what the temperature of the glass is. So it broke because it was cold. Again, for us, that's around 1,000 degrees. Really, we're describing that that glass is rigid and it's no longer moving. So it takes a while to build the heat back up in the material, to soften it, to keep working. Now Catherine, she's just working with clear glass. However, if she wanted to add color, she would have done that at the very beginning. We have these crushed pieces of colored glass. This is called frit. We can roll molten glass right across these chips. They'll heat up, they'll stick, and we can melt them in smooth. So it's a fast, easy way to apply color to anything that we're making. And we have a couple hundred color options to choose from. There's a manufacturer in Germany, they make this colored glass. They've been making glass color for nearly 2 centuries, so they are very good at it, and they're very reliable. This is Rosetta green. We could order this Rosetta green from the Reichenbach factory in Germany, and 5 years from now, we could order this Rosetta green, and it would come to us and be the exact same. So it's really easy for us to just buy it from them. But they make the different colors by adding different metals to the glass. So that green is probably made with iron oxide, essentially rust. But check this out, this is very cool. Catherine cuts through glass with a pair of shears. Glass is very easy to cut through as long as it's hot. When it's hot, it's soft, it's squishy, it's malleable. But if you noticed, as quickly as she cut through the glass, she has to get right back to the reheating furnace. That's because at this point, that working time is really short. We maybe have 15 or 20 seconds to change the shape of the glass before it's cooled down, before it becomes rigid again. So we work really quickly through those steps and through that process. Now, Catherine's also focusing heat on just the part she wants to change, so just the very top, where she plans to open this up to be a bowl. Every once in a while, she does put the glass into the reheating furnace, all the way into the reheating furnace, to maintain temperature all the way back at that punty connection. That glass is stuck onto the punty again because of the temperature, and if we let it get too cold, it can fall right off the end of the pipe. But she's folded the lip back onto itself. She opened it, rolled it over onto itself to create a little ring of double thickness. Sure. Okay. How about you tell me when? All right. I was wrong. It's not going to be a bowl. I thought she was going to make a bowl. It's not going to be a bowl. Catherine is going to make a glass basket. So it should be very exciting. I'm going to open this up quite a bit larger. We'll also get to add a handle because the basket needs a handle. So she'll continue to open this up a little bit bigger. I told her to tell me when she needs that handle. It's pretty common to work as a team. Look at this. She's opening this up much bigger and wider just without even touching the glass. She let it get really hot. And by turning quickly, some centrifugal force spins the glass open into a larger, wider shape, and then she's able to hold the glass up towards the sky. By doing that, it starts to fold back over onto itself to create a nice little folded top to the basket. So while she finalizes the shape of the basket top, I'm going to get started on the handle for the basket. So I'll get some more glass. Now, this clear glass that I have, if I just bring this to Catherine, just a big hot glob of glass, it'd be very difficult for her to turn it into a handle. So just like you can roll clay or Play-Doh out on a table, I'm going to roll our glass out on our table. We call this the marver, and we marver the glass. We roll it on the table to shape this up and to cool the glass, to give it a little bit of structure. So I can roll this out into a cylindrical form. Catherine, do you want me to square this up a little bit? Okay. All right. So Catherine's the designer. She's the person in charge. So I refer to her for what she needs and what she wants for the design. Just make a couple more adjustments to the top of this for the basket shape. Now those of you in this area, can you feel the heat from the furnace with all these doors open? Tell you what, I can too. Catherine can as well. But we do have all these sets of doors so we can make larger and larger work. We just keep opening the doors so we can make larger pieces. All right, here we go. We're going to add a handle. So I dropped this handle into a mold as well so we get some texture on the surface of this glass. Now I just have this vertical texture But by turning, I can twist it, I can stretch it, Catherine stretches it across the top, she cuts it onto the top, and now she can stretch this glass out to turn it into her final handle shape. That's really difficult to do, get that stretched all the way across. Now that handle, it's the hottest thing into the reheating furnace, so it'll be the hottest thing back out of the reheating furnace, so she will have a few moments to make some final adjustments to that handle. So holding the glass towards the ground, swinging it back and forth helps stretch and elongate the handle. Catherine, what would you like to put in this basket? Flowers. It's a flower basket. Nice. So, to put flowers in this basket, this is still very, very hot. To keep this, we need to slowly cool our glass. If we just let this sit out in the open air for even a matter of minutes, it would break itself apart. So we have to slowly cool everything that we make through a process called annealing. So we will anneal this glass. We'll slowly cool it. We'll load it into a 900-degree oven on the side of the stage. We will anneal this glass. We'll slowly cool it. Everything that we make, that cooling time, it's determined by the thickness of the glass. And this piece is fairly thin. So we'll cool this overnight, 8 and 10 hours, no problem. We'll see it again tomorrow. But a little bit of water on that punty creates additional thermal stress. A light tap, the piece breaks free. There it is, beautiful glass basket. So I'll tuck this away. Put everything on the left side today. There we go, plenty of room here. The right side of the oven. Tuck that away. We'll see it again tomorrow. Catherine can bring some flowers for the basket. Beautiful job. How about one more round of applause? That's Catherine Ayers.